Now let's look at another question over here. We have PQ is given. Okay, PQ is actually y equal to 4 over 5x plus 3. Okay, now to find the y-intercept of PQ, what would you do? Now at the is x-intercept. Now if you have an equation, you have a line. Let's say you have a line that passes through here. Okay, now let's say this line is y equal to 4 over 5 x. Oh, it's plus 3, so let's redraw it slightly. Now, line. Why teacher redraw the line? Mainly because y equal to 4 over 5 x plus 3. Okay, this is the y-intercept, so it should pass through 3 here. Okay, now what we're going to find is here, what is the x value, but we know the y is 0 for the x-intercept. Okay, let me repeat. The x-intercept is this point here, where the line intersect with the x-axis. The y value at this point is actually y equal to 0, because this point here is y equal to 0. So any point on this line, y is equal to 0. Now we're going to find this value. Okay, let's put it as x. Okay, this value is x. Now, so we're going to take the equation y equal to 4 over 5 x plus 3. Now, if this x-intercept is actually on this line, okay, now so we can substitute into here. So remember, y equal to 0. Okay, when you want to find the x-intercept, your y must be 0. Then 4 over 5x plus 3. Now, so it's minus 3 equal to 4 over 5x. So remove this, the 5 go up, become minus 3 times 5. This is numerator, go down as denominator, that's an x. So it's minus 15 over 4 equal to x. That gives you minus 3 over 4, that's your x. In other words, this point here is actually minus 3 and 3 over 4. Therefore, this point here is actually the x-intercept. Okay, so what you write here is x-intercept is basically minus 3 and 3/4 and 0. Okay, that's it. Now find the equation of the straight line SR. They are parallel. So SR, the M of SR must be same as the M of PQ. Now let's look at PQ. PQ, what is the M? The M is 4 over 5. So the M of SR is also 4 over 5, since they are parallel. Okay, now we also given a point R. You see this equation SR is actually, this S actually is on this line. That's why the R and the R is the same point. That means to say this line SR actually, besides having the gradient 4 over 5, is actually passed through S also. Okay, so this is 5 minus 6. Now let's get this line SR. Okay, a line SR means this line actually passes through the point S and R. Okay, S is given. Okay, so in other words, this line SR, besides having the gradient of 4 over 5, which is similar with PQ, which is 4 over 5, we also pass through the point 5 minus 6. So again, we use the same formula, y minus y1 equal to m x minus x1. Okay, so y minus y1 is minus 6, m is 4 over 5. Since it's parallel with PQ, we're going to take from here 4 over 5. Okay, then x minus x1, which is 5. Now simplified further is y plus 6 equal to 4 over 5x. Okay, minus this x minus 4 over 5 times 5. Cancel. So what you have is 4 over 5 x minus 4. Okay. Now, so I'm going to simplify it further. So y, the 6 here, I'm going to bring it over to the right hand side. So it's 4 over 5x minus 4. We bring over, become minus 6. So it's 4 over 5 x minus 10. Okay, so this is the equation of line SR. Okay. Okay, now AB is parallel with DCE. Okay, find the gradient of line AB. Again, same thing. The M is actually y1 x1 minus y2 over x2. Why we use these? Because there are two given points for the line AB. So let's say this is point 1, this is point 2. No. So point 1 become 1, which is the y1, and then x1 is minus 3, minus. Now point 2, y is 9, x is 5, so you get minus 8 over minus 8. Cancel the minus, simplify that, so become 1. In other words, this line here, ABM is equal to 1. Okay, so M, the gradient of line AB is equal to 1. Okay, since this is parallel with this, so the M here should be also equal to 1. Okay, now why this is given? Because this is there is another page that will continue from question 7. We'll look at it later.